So like I said, this is exactly what we've been doing. It's problem solving with units. So we're just going to kind of continue down that path. Oh, it's great. My Apple Pencil just ran out of batteries. All right, so it is good to take an approach like this. When you're using unit analysis to problem solve and you're given this big confusing word problem, it's best to work your way backwards. So first identify the units involved and specifically identify the units that you expect for the answer. So once you can figure out the units that you expect for the answer, you can go in and extract the information you're given and just have normally a longer multiplication problem where you're using unit analysis, making sure the units in the numerator properly cancel with the units in the denominator and leave you in the units you want at the very end. And so then the real key, as I have kind of said from the beginning of this section, is you want to make sure to perform all operations on both numbers and associated units. We are not just doing straight arithmetic with numbers and then attaching units on the end. We're making sure to go through every number in there should have a unit attached to it. All right, so give me a green check when you're good with this slide. So you're buying 30 acres of farmland for $12,000 per acre. What is the total cost? So right away I see that I expect my final answer to be just dollars. Total cost is just dollars. All right, so I want to work at using this information to be just left with dollars. All right, so what's the information that I'm given? I'm given that I have 30 acres and it cost $12,000. I did not space that properly. Don't judge me, I'm using my finger and not my Apple Pencil. $12,000 per acre. That's 12,000 in the numerator per 1 acre in the denominator. And so if we just make this a fraction, just put it over 1 and multiply it, notice that acres cancel. I'm left with the dollars that I want. And so I'm ready to go. Just multiply 30 times the 12,000. And I get $360,000. So that's kind of an example of how we work our way backwards. Take a look at the units you want to end up with. And look at what they give you to figure out how to properly combine them, usually through multiplication or division, so that the units will properly cancel and leave you with what you want at the end there. All right, let's move on to the next one. So this is akin to what we did in the beginning of class when somebody was asking about that number 95. So we're planning to make a pesto and we need to buy basil. At the grocery store, you can buy small containers of basil priced at $2.99 for each 2/3 ounce container. And at the farmer's market, you can buy basil in bunches for $12 per pound. Which is the better deal? So anytime you're trying to make a comparison, you just need to get the same units to compare, right? So here are the units we have right now. We're given grocery store units, which is $2.99, $2.99 per, remember per means divide, 2/3 ounce. So my grocery store is in dollars per ounce. My farmer's market is $12 per 1 pound. So my farmer's market is dollars per pound. So now you have a choice to make. Do you want to simplify this to dollars per ounce for both of them, or do you want to simplify both of them to dollars per pound? It really doesn't make a difference which, as long as you get the same units so you can make a proper comparison across. So I'm gonna say let's simplify to dollars per ounce. So the first thing I want to do is just divide out the 2.99 and the 2/3 so that I'm in specifically dollars per 1 ounce, right? So in our calculator, we're just going to do 2.99 divided by, now this is important, open parentheses, 2 divided by 3, close parentheses. So I get 4.485. So we'll just round that to the nearest cent. So $4.49 per ounce. All right. So for farmer's market, we need to convert pounds to ounces. So we're going to jump to our conversion chart. So pounds to ounces, those are both US measures. So those are weights. There we go. 1 pound equals 16 ounces. So 1 pound is 16 ounces. So I want pounds in my numerator, right? So 1 pound per 16 ounces. And I'm going to make sure that my units divide out the way I want. Pounds divide out with pounds. And I'm left with dollars per ounce, which is exactly what I want. So when we multiply these across, we get 12 over 16. 12 divided by 16 is 0.75. So $0.75 per 1 ounce. So is it better to shop at the grocery or the farmer's market? It's much cheaper to buy basil at the farmer's market because it's only 75 cents per ounce of basil versus at the grocery it's $4.49 per ounce of basil. But then you also have to do your cost benefit analysis of, are you going to use a pound of basil? That's a lot of basil to consume. All right, give me a green check when you're good with that one and we'll move it forward. All right, just another example. We're just going to keep coming with these. Your destination is 90 miles away and your fuel gauge show that your gas tank is 1/4 full. Your tank holds 12 gallons of gas and your car averages 25 miles per gallon. Do you need to stop for gas? Okay. So I think the easiest way to approach this is figure out how many gallons it'll take you to travel 90 miles. And then how many gallons in 1/4 tank, which is what you have. And then we'll just compare them. All right, so in both situations, we want to end up in gallons of gas, right? I'll just private message that it takes a lot of basil to make pesto. A pound? It's like a bushel this big of pesto. All right. I guess you could dry the basil, but that's an. All right, so let's do this. So in both cases, we want to end up in gallons. So in case one, we're given that we need to drive 90 miles. The other piece of pertinent information is we're given our fuel efficiency. We get about 25 miles per gallon. So that's 25 miles per gallon. But I don't want to end up with miles squared per gallon. So what I'm going to do is take the reciprocal of that. I'm going to flip it, and I'm going to say, oh, well, 1 gallon gives us 25 miles, right? So 1 gallon per 25 miles. And now you'll notice that when we multiply these, we're left with the units we want. We're left with gallons. So I'm going to multiply those out. I'm going to end up with 90 over 25. And gallons is going to be my unit. So 90 divided by 25 is 3.6 gallons. So that's what it's going to take for us to drive 90 miles. Now 2, we know we have a quarter tank of gas. And the other information is that our tank holds 12 gallons of gas. So that's another way of saying that is it's 12 gallons per 1 tank. So if I multiply that out, that's going to, again, just leave me in gallons like I wanted. So a fourth of 12 is just 3. So we have enough gas to get us 3, we only have 3 gallons of gas in the tank, I should say, and up here we figured out that it would take us 3.6 gallons to drive the 90 miles, which is going to tell us that if we're smart, we will stop for gas. Yeah, I've made pesto. You guys are raking me over the coals about pesto. I'm just saying a pound. I think you'd be surprised to know what a pound of a leafy green vegetable looks like. Like even those big clamshells of salad that you'll get at like the store, that's not a pound of. Yeah. Oh, that works. There are other ways to make this comparison. We could have calculated how far we could travel on our tank, right? We could have easily just done away with this entire calculation, figured out we have 3 gallons of gas, and then calculated how far that would get us, and then compare that to the 90 miles. Absolutely. And you would get something under 90 miles, right? So there are multiple ways you could do this. I'm going to save these last couple examples. So these are kind of boss level. You can get started for sure on the 2B problem set. It's just more problems like this. We're going to need some new measures, which we'll go over next time. So like measures of energy and power. What's a joule? What's a watt? What's a kilowatt? And then different measures of density. But other than that, the examples are just the exact same thing, trying to make sure that you are canceling units out, showing proper unit analysis, okay? So get started on 2B. 2B won't be due until Tuesday, but it will be due along with till Monday. along with the 2A, 2B review, okay? So if you haven't finished 2A, finish that, turn it in, get started on 2B, and then we'll finish the last two examples on Wednesday, and I'll give you the rest of the time to work on the 2B problem set and the review as well.